So we just wrapped up section 2.1 dealing with energy sources. Now we're going to turn our attention to section 2.2 dealing with energy applications. Today's lesson is going to focus on alternative fuels and advanced technology vehicles. More than a dozen alternative fuels are in production or under the development for use in advanced technology vehicles in order to improve our means of transportation. Government and private sector vehicle fleets are the primary users for most of these fuels and vehicles at this time. However, there's individual consumers that are increasingly interested in them. Using alternative fuels in advanced vehicles instead of the conventional ones will help the U.S. not only conserve fuel, but lower vehicle emissions. Conventional energy sources come primarily from fossil fuels, such as coal, natural gas, and petroleum. Oil is perhaps one of the most common and conventional sources of fossil fuel energy production. It keeps the nation's transportation systems moving through the production of gasoline, diesel, and aviation fuel. And the cost effectiveness of these fuels is a critical element of business operations within our economy. Coal serves as an effective heat energy source, and it is used in electricity generation and as fuel for power plants. Natural gas is growing in popularity as a conventional energy source because of the vast underground reserves found in the U.S. However, as we move forward, a number of experimental and non-conventional energy sources, also known as alternative fuels, are on the horizon so that we can gradually shift our reliance from these conventional fuels to other cleaner and more efficient fuel sources. The selection of alternative fuels is based on the 3 E's: to become more eco-friendly, more efficient, and more economical. We are looking to these alternative fuels because we know that conventional fuels will eventually run out to overusage. They also reduce pollution. They also protect us from global warming. They're cost-effective, non-toxic, and they're much easier to handle and store. The types of alternative fuels and vehicles that we're going to be looking at in today's lesson include blending biodiesel into petroleum diesel vehicles, using electricity to power electric and hybrid vehicles, and blending ethanol into gasoline-powered vehicles. Tomorrow, we'll turn our attention to a few other alternative fuels, including hydrogen, natural gas, and propane, as well as look at their benefits. Let's go ahead and start with biodiesel. Biodiesel is a domestically produced, renewable fuel that can be manufactured from new and used vegetable oils, animal fats, and recycled restaurant grease. Both biodiesel and petroleum diesel are used to fuel compression ignition engines, but biodiesel is a much cleaner burning renewable alternative. As a result, using biodiesel in place of petroleum diesel significantly reduces life cycle carbon emissions, and research shows that it also reduces emissions of toxic air pollutants in older on-road vehicles and in many off-road applications. One thing to consider is that all diesel and biodiesel blends can have compounds that crystallize in very cold temperatures, causing the fuel to turn into a gel-like substance, causing operability issues if not properly monitored. However, fuel blenders have a number of options available to improve the cold flow properties of biodiesel blends, including adding flow improvers. So as we continue on with our learning of biodiesel, let's take a look at a few benefits and considerations. First off, biodiesel is produced in the United States and it's used in conventional diesel engines, directly substituting for or extending supplies of traditional petroleum diesel. It is a clean-burning, renewable substitute for regular petroleum diesel. Using biodiesel as a fuel improves not only its energy efficiency and costs, but it also improves the air quality, the environment, and it provides a variety of safety benefits. In regards to energy and cost, using biodiesel and other alternative fuels and advanced technologies to reduce fuel consumption continues to reduce transportation energy costs for businesses and consumers alike. Soybean biodiesel has a positive energy balance, meaning that soybean biodiesel yields 4.56 units of energy for every unit of fossil fuel energy consumed over its life cycle. In regards to air quality, Using biodiesel reduces life cycle emissions because carbon dioxide released from biodiesel combustion is offset by the carbon dioxide absorbed from growing soybeans or other feedstocks used to produce the fuel. Life cycle analysis completed by Argonne National Laboratory found that biodiesel in its purest form can reduce carbon dioxide emissions by 74% compared with petroleum diesel. Biodiesel also improves fuel lubricity. This is important because diesel engines depend on the lubricity of the fuel to keep moving parts from wearing prematurely. Biofuel also has some safety benefits, and the fact that its pure unblended form causes far less damage than petroleum diesel if it's spilled or released into the environment. It is safer than petroleum diesel because it is less combustible. The flash point for biodiesel is higher than 130 degrees Celsius compared to about 52 degrees Celsius for petroleum diesel. This implies biodiesel is less of a fire hazard and therefore safer to handle, store, and transport. There are a growing number of biodiesel fueling stations available across the United States. You can go ahead and take a moment and use this link on this page to view the locations of these alternative fuels, including biodiesel. Biodiesel and conventional diesel vehicles are one and the same. Almost all light, medium, and heavy-duty diesel vehicles are capable of running on biodiesel blends. Go ahead and take another moment to click on the link to view the fleets of biodiesel vehicles that are in production for the year 2021. Let's go ahead and turn our attention to electricity and see how electricity can be applied to electric vehicles. Recall that electricity can be produced from a variety of energy sources. We saw it could be produced from oil, coal, nuclear energy, hydropower, natural gas, wind, solar, and even stored hydrogen. Plug-in electric vehicles, which is the collective term for plug-in hybrid electric vehicles, and all other electric vehicles, are all capable of drawing electricity from off-board electrical power sources and storing it in its batteries. In plug-in electric vehicles, onboard rechargeable batteries store energy to power one or more electric motors. Vehicles that run only on electricity produce no tailpipe emissions. Fueling these plug-in electric vehicles with electricity is currently cost-effective compared to using gasoline, but they typically cost more to purchase. However, initial vehicle costs can be offset by fuel cost savings, a federal tax credit, and even statewide incentives. Many owners of plug-in electric vehicles choose to do the majority of their charging at home or at fleet facilities in the case of commercially owned fleets. Some employees offer access to recharging at the workplace. In many cities, plug-in electric vehicle drivers also have access to public charging stations in a variety of places, such as at shopping centers, public parking garages and lots, hotels, and gas stations and businesses. Charging infrastructure is rapidly expanding, providing drivers with the convenience, range, and confidence to meet more of their transportation needs with the plug-in electric vehicles. Let's go ahead and take a look at the benefits and considerations of using electric vehicles. Both hybrid and plug-in electric vehicles can help improve the fuel economy, lower fuel costs, and reduce emissions. Hybrid and electric vehicles typically achieve better fuel economy and lower fuel costs than similar conventional vehicles because of their high efficiency of electric drive components. For example, fueleconomy.gov lists the 2019 Honda Accord hybrid at an EPA combined city and highway fuel economy estimate of 48 miles per gallon, while the estimate for the conventional 2018 Accord, which is a 4-cylinder automatic, is 33 miles per gallon. You can go ahead and take a minute to use a Find a Car tool on fueleconomy.gov to compare fuel economy ratings of individual hybrid and conventional models. Hybrids and electric cars also have the benefit of flexible fueling. Since the electric grid is in close proximity to most locations where people park, they can charge their cars overnight at a residence, as well as at a fleet facility, workplace, or public charging station when available. Hybrids have added flexibility because they can also refuel with gasoline or diesel, or possibly other fuels in the future when necessary. Another nice benefit to purchasing electric vehicles is that you can earn a tax credit. Although fuel costs for hybrid and plug-in electric vehicles are generally lower than the similar conventional vehicles, purchase prices can be significantly higher. However, prices are likely to decrease as production volume increases and battery technologies continue to mature. Also, initial costs can be offset by fuel cost savings, which I said it could be in the form of a federal tax credit or other state incentives. The federal qualified plug-in electric drive motor vehicle tax credit is available for both hybrid and electric vehicle purchases until manufacturers meet certain thresholds of vehicle sales. It provides a tax credit of $2,500 to $7,500 for new purchases, with the amount determined by the size of the vehicle and the capacity of its battery. Both hybrid and plug-in electric vehicles have significant emissions benefits over conventional vehicles. Electric cars produce zero tailpipe emissions, and hybrids produce no tailpipe emissions when in all electric mode. In regards to the batteries found on both hybrid and plug-in electric vehicles, we can see that they are designed for extended life, but they will always wear out eventually. Several manufacturers of plug-in vehicles are offering an 8-year, 100,000-mile battery warranty on these types of vehicles. Although manufacturers have not published pricing for replacement batteries, some are offering extended warranty programs with monthly fees. If the battery is needed to be replaced outside the warranty, it could be significantly higher in expense. Battery prices are expected to decline as battery technologies improve and production volume increases over time. Tens of thousands of electric vehicle charging stations are found all over the United States. Take a moment to click on this link to see where these stations are available. Charging stations are being installed in key areas throughout the country for public charging, workplace charging, and even for residential charging. Hybrid electric vehicles, plug-in hybrid electric vehicles, and all electric vehicles all use electricity either as their primary fuel or to improve the efficiency of conventional vehicle designs. Today's hybrid electric vehicles are powered by an internal combustion engine in combination with one or more electric motors that use energy stored in batteries. These hybrid electric vehicles combine the benefits of high fuel economy and low tailpipe emissions with the power and range of regular conventional vehicles. A wide variety of hybrid electric models are currently available. You can select this link below to get these in greater detail. Although they are often more expensive and similar to conventional vehicles, some of the costs again can be recovered through fuel savings through state and federal incentives. It's important to note that a hybrid electric vehicle cannot plug into off-board sources of electricity to charge the battery. Instead, the vehicle uses regenerative braking in the internal combustion engine to charge itself. The vehicle captures energy normally lost during braking by using the electric motor as a generator and storing the captured energy in the battery. Feel free to visit the link at the very bottom for an animation of how the hybrid electric vehicle works. Plug-in hybrid electric vehicles use batteries to power an electric motor and use other fuels such as gasoline or diesel to power an internal combustion engine or other propulsion source. Using electricity from the grid to run the vehicles some or all of the time reduces operating costs and fuel use relative to the conventional vehicles. Plug-in hybrid electric vehicles may also produce lower levels of emissions depending on the electricity source. There are several light-duty plug-in hybrid electric vehicles commercially available, with medium-duty vehicles are now entering the market as well. Both medium and heavy-duty vehicles can also be converted to plug-in hybrid electric vehicles, but at a higher cost. Although plug-in hybrid electric vehicles are generally more expensive than similar conventional and hybrid vehicles, again, these costs can be saved through federal and state incentives. Plug-in hybrid electric vehicles have an internal combustion engine and an electric motor, which uses energy stored in the batteries. They generally have a larger battery pack than the hybrid electric vehicles themselves. This makes it possible to drive moderate distances using just electricity, about 10 to 50 plus miles in current models, commonly referred to as the electric range of the vehicle. For example, during urban driving, most of the plug-in hybrid electric vehicles' power can come from the stored electricity. A light-duty plug-in hybrid electric vehicle might drive to and from work on all-electric power, plug the car in the charge at night, and be ready for another all-electric commute the next day. The internal combustion engine powers the vehicle when the battery is mostly depleted, during rapid acceleration, or when intensive heating or air conditioning loads are present. It's important to note that plug-in hybrid electric vehicle batteries can be charged by an outside electrical power source, by the internal combustion engine, or through regenerative braking. During braking, again, the electric motor acts as the generator, using the energy to charge the battery. Plug-in hybrid electric vehicles' fuel consumption depends on the distance driven between battery charges. For example, if the vehicle is never plugged in to charge, fuel economy will be about the same as a similarly sized hybrid electric vehicle. If the vehicle is driven a shorter distance than its all-electric range and plugged in to charge between trips, it may be possible to use only electric power. All electric vehicles use a battery pack to store the electrical energy that powers the motor. Their batteries are charged by plugging the vehicle into an electric power source. Although electricity production may contribute to air pollution, the U.S. Environmental Protection Agency categorizes all electric vehicles as zero-emission vehicles because they produce no direct exhaust or emissions. Both heavy-duty and light-duty electric vehicles are commercially available. You can go ahead and select this link to see what those are. As I've stated before, all electric vehicles are typically more expensive than the conventional or even hybrid vehicles, but again, the cost can be recovered through fuel savings and federal and state incentives. Today's all-electric vehicles generally have a shorter range per charge than comparable conventional vehicles have per tank of gas. The efficiency and driving range of all electric vehicles varies substantially based on driving conditions. Extreme outside temperatures tend to reduce that range because more energy must be used to heat or cool the cabin. High driving speeds reduce range because of the energy required to overcome increased drag. Compared with gradual acceleration, rapid acceleration will also reduce its range. Hauling heavy loads or driving up significant inclines can also reduce its range as well. And finally, let's turn our attention to ethanol. Ethanol is a renewable fuel made from various plant materials, collectively known as biomass. More than 98% of the U.S. gasoline currently contains ethanol to oxygenate the fuel, which reduces air pollution. There are several steps involved in making ethanol available as a vehicle fuel. First, biomass feedstocks are grown, collected, and transported to an ethanol production facility. Those feedstocks are then converted to ethanol at a production facility and transported to a fuel terminal or end user by rail, truck, or barge. Ethanol is then blended with the gasoline at the fuel terminal to make either E10, E15, or E85. All three of these are different blends of ethanol and gasoline, and they're distributed by truck to the fueling stations. Ethanol's impact on fuel economy is dependent on the ethanol content in the fuel and whether an engine is optimized to run on the gasoline or the ethanol. Let's go ahead and look at the benefits and considerations of using ethanol. A gallon of ethanol contains less energy than a gallon of gasoline, resulting in lower fuel economy when operating your vehicle. The impact of fuel economy varies depending on the energy difference in the blend used. Ethanol also has a higher octane number than gasoline, which provides increased power and performance. Ethanol production also creates jobs in rural areas where employment opportunities are needed. According to the Renewable Fuels Association, ethanol produced in 2019 accounted for more than 68,600 direct jobs across the country, $43 billion to the gross domestic product, and $23 billion in household income. Ethanol can also lower emissions. The carbon dioxide released by a vehicle when ethanol is burned is offset by the carbon dioxide captured when the feedstock crops are grown to produce that ethanol. Lower level blends require no special fueling equipment, and they can also be used in conventional gasoline vehicles. Fuel providers can offer E15, E85, and other ethanol gasoline blends. E85 and E15 are available at over 3,500 and 2,000 fueling stations, respectively. The alternative fueling station locator allows users to search for public and private E85 fuel stations. To see where those alternative fueling station locators are, go ahead and select this link. The vehicles that are able to blend both gasoline and ethanol together are called flexible fuel vehicles. Flexible fuel vehicles have an internal combustion engine and are capable of operating on gasoline and any blend of gasoline and ethanol up to 83%. E85 or flex fuel is a gasoline ethanol blend containing 51% to 83% ethanol, depending on geography and season. According to data gathered in 2017, there was more than 21 million flexible fuel vehicles in the United States. Because these cars are factory made and are capable of operating on gasoline and gasoline ethanol blends, many vehicle owners don't realize that their car is actually a flexible fuel vehicle and that they have the choice of fuels to use. Go ahead and visit fueleconomy.gov to learn how to identify any flexible fuel vehicles or use the alternative fuel and advanced vehicle search to find any current flexible vehicle models. And so just to summarize the last few slides, I really like this picture as it demonstrates the three different options for flex fuel, hybrid, and electric vehicles. So again, with flex fuel, these vehicles have a combustion engine that are designed to run on a mix of conventional gasoline and fuels made from alternative sources such as sugarcane or corn. With hybrid vehicles, they're powered by two or more fuels. The most common type of hybrid vehicles have electric drivetrains, which are powered by a battery. When this battery depletes, the internal combustion engine acts as a generator to recharge the battery. And then in all electric vehicles are powered entirely by the rechargeable batteries and have electric powertrains.